Hi, we are group 15 and we are giving an elevator pitch for the paper Learning to Cache with No Regrets. The goal of this paper is to propose a caching policy and an analysis that optimizes the performance of caching systems under any distribution of the file request sequence. The approach considered in this paper is that it first fits the caching problem into an online linear optimization framework. To briefly describe online linear optimization, it is an optimization problem wherein we make decisions in an online setting, and the data is revealed to us at different time slots. The main objective there is to minimize the cumulative loss that is incurred when making a sequence of decisions over time. The second step in the approach is to improve the regret lower bounds for any caching policies. Followed by that, we come up with caching policies that have minimum regret in both single cache and caching networks cases. To evaluate the performance, regret is used as the performance metric. Online gradient ascent is a minimum regret caching policy under that comes under online linear optimization framework. What it does is it updates the weights of the files in the cache based on the gradient of utility taken with respect to the weights. It is a universally optimal policy for caching problem in OLO framework, as it meets the lowest lower bound of regret that was proved in the paper, which is of the order root T. It is better than the lower bound of existing caching policies, which is of the order T. The performance evaluation that is discussed in the paper is given here. The conclusion here is that the OGA performance is always close to the best among LFU and LRU policies. And the benefits are as high as 16% over LRU and 20% over LFU.
Hello, let's talk about caching networks. Caching networks are a group of interconnected caches that jointly make decisions on which cache will deliver a request or which files to remove from the caches. Currently, there are some algorithms like lazy LRU and MLRU that work for cache networks, but they only work for stationary requests and they do not adapt with the changes in popularity model. So we propose bipartite subgradient algorithm that does not make any assumptions about the order of the incoming requests, and it adapts well to the changing popularity model as well. It computes subgradient of regret function with respect to cache contents to adjust the caching decisions. It also uses utility vectors and it assigns utility values to cache nodes. So how it works is when there is a popular file, it will place that file on a cache node of higher utility. The utility can depend on several criteria like delay, cost, or closeness to any user location. We prove that BSA has zero regret and it works optimally for any online request sequence. By using simulations, we also prove that BSA outperforms lazy LRU by 48%, and it gives average utility close to the best caching policy in hindsight. Coming to the applications, it can be used in virtual reality, which is compute heavy and sensitive to delays. It can also be used in dynamic resource allocation in distributed systems, as well as recommendation systems. Coming to the conclusions, I would say that we proposed a caching policy that can adapt to changes in popularity of files, and it makes no assumption about file request sequences. We show that OGA and BSA are universally optimal and achieve best possible lower and upper bounds on regret. That's all from our end. Thank you.